Hey there, Braden. I wanted to cover two things in this video. First thing, just to talk about something that I've created, and I'll update it to the BRAT website, is just installing the correct wheel files and what are some tips for getting your PC ready and ArcGIS ready so that you have the correct wheel files like for GDAL and floppy and NumPy. We do have a great video that Jordan put out, but these are just some tricks that I figured would be helpful for people, and so I'll update the website for it, but just so you know, that's something that probably will do. Second is concerning the confrontation of your question. So talked about editing for the inputs, and so I think the first thing is that I do see inputs and the editing of them or the coding of them to be highly helpful. Just to start out, these are the inputs for the tool as far as I remember, and I should probably make sure this is what he has, what Conrad has in his tutorial for input. So he has the BRAT shapefile, he has a DEM, he has a flow accumulation raster, and then all these other rasters from the and he has a flow direction raster. So flow accumulation, flow direction, and those inputs up there for the flow accumulation, DEM, BRAT, and flow direction, I think just working with the tool, like those are all inputs that we'll be able to grab from the tool, and it won't be too big of an issue. The soil data is what needs to be generated, and I think that it needs to be coded to do this. Conrad did talk about, some in this document that I did send you. It's Matthew Meyer BDWS update. It talks about, what Conrad suggests. He said he created these raster files using the map unit key field in the attribute table of the GSS Surgo data. So if you go to the GSS Surgo data and you just look up here, there's a map unit key field. Okay, this corresponds to like a table that holds all these different values, and I don't think it's the one that I just had up. Like I don't think it's this one. It's like a different file, but there's a key that goes with it that does talk about, all right, these are the in our particular situation, these are the field capacity values for that map unit key. Okay, these are the K saturation in the horizontal, or the saturation of the soil in the horizontal. This is the saturation of the soil in the vertical. So those are the three TIFF files that we need generated. And from what I remember in speaking with Conrad about is that, this data set, you can base it off of a 90-meter raster. I found that there was this 10-meter map unit raster, and it does have MU keys, and the way that I found that was just with, let me get to it. Okay, so if you just go to the USDA gateway, you can see in here there's the GSS Surgo and the SS Surgo. Those are files that you can do. and it just downloads it for the whole state, okay? And you can just get that data. The trick is converting the data using this map unit key. So you're using the map unit key to identify the location of each of these raster cells that you're going to do, but you're giving them new raster values, new cell values. Okay, so we'll specifically go to this one, and we'll turn off the imagery. We're just right below Bear Lake, basically. So what Conrad had done was he created this new file, okay, and let's make sure that we've got, so you can go into, if you're ever having a hard time with a raster data set, you can go into display or symbology and click on classify or unique values, and it will give you like unique values for each one of those, and you can symbolize it accordingly. But oh, it didn't work this time. Never mind. Anyway, just symbolizing rasters, right? Sometimes you can go in there and it will actually give you like a new way of presenting it. But anyway, in this case, you've got the new values for the raster, okay, based on this field capacity. I believe it's field capacity. Yes, field capacity was, and it has explanations of each one in there. So you have these cells that have the values for the field capacity, and what he did was he clipped them to the valley bottoms. The reason why he did that was to cut down on processing, and that would be pretty easy given that, you know, you're not really given like this watershed boundary for the BRAT inputs, but you are given a valley bottom for the BRAT inputs, and that would give you a polygon to clip with, and it cuts down the processing time drastically. So, which is a great thing. Always what we want to do is cut down processing time if we are able to get good results. So what he did in here was he just gave, clipped each one to the valley bottom, okay, through the horizontal saturation, which is the, saturation of the soil in the horizontal direction and saturation of the soil in the vertical direction. Once you have those, we can move on to the next step in creating massaging some of the inputs. Basically, Conrad's tool, the BDWS script as it is, has some defaults in there that we might want to give the user an option to tweak, given that he just ran it on this watershed, just the Bear River watershed, and so he customized some variables in there. Didn't really give an option for those. A good example of this is the groundwater table. I discussed this earlier as being, I wonder if it's here. Okay, yeah. So just to talk about the water table depth, he gave it a value of like 10, I think, and in different watersheds, it's going to be different for the water table depth, and that would be something good for the user to do, and we can talk about some other things that would be nice to make some user inputs. But read this document that I sent you, and it should talk or give you a good idea of how you can move forward. Give me a call if you have any questions, and that'd be great. All right.